Hello and welcome students once again to another video class for grade 9th mathematics. And today we'll be discussing the last portion for chapter number 13, that is surface areas and volumes. That is all about sphere and hemisphere. So welcome to the lesson on surface area and volumes of sphere and hemisphere. So hopefully at the end of this module, you will be able to understand these following concepts: that how to identify a sphere and a hemisphere, and calculate the surface area and the volume of a sphere and hemisphere. So let's start with this. So basically, first we should know that what basically a sphere is. So a sphere is a three-dimensional figure, okay, and which is made up of different points which are equidistant from a given point. Okay, and it is round in shape, which is having no edge or a vertex. Okay, so no edges, no vertices in case of a sphere, and its surface is uniform and is smooth. Okay, as you can observe, due to which they can move freely, okay, onto the surface. So basically, let's understand some basics about the sphere, which is the first start with center. So center is a point which is equidistant from all the points on the sphere, okay, and the distance between the center and any point on the surface of the sphere is called the radius of the sphere, okay, and it is denoted by r, allows of and the line passing through the center and joining two points on the opposite sides of a sphere, that is called as the diameter of a sphere, right? So the diameter is equal to twice of radius, that all of so denoted by letter D. Okay, so these were the fundamentals. Now let's move to the surface area of a hemisphere. Sphere first, then we'll proceed to hemisphere. So the surface area of a sphere is the total exposed area of the sphere, as you can see. So let's understand this with the help of an example. So observe this sphere carefully. So let's draw a line. So from one point to another on the opposite sides of the sphere, and we'll paint on the one side of the line, that is the right hand side, as you can see, to the other side also. Then now you can see that the whole painted area of this sphere represents the surface area of this particular sphere, okay. An example that will help you to easily understand this is, for example, let's take an orange. So if we'll peel off the skin of an orange, so the area of the skin represents the surface area of the orange, got it? So in this way we can understand that the surface area of a hemisphere, and let's see how we can calculate the surface area for a sphere in mathematical form. So now we can find by using this formula, that is 4 pi r square. Surface area of a sphere can be defined as, in mathematical form, that is 4 pi r square, where r is the radius of that given sphere, okay. So this is the total surface area of a sphere, that is 4 pi r square, because in a sphere you can see that we are having no flat surfaces, only one curved surface is there. So don't get confused with CSA or LSA, because just one surface we are having, that is curved surface, okay. So basically we are having this total surface area of the sphere, that is 4 pi r square. Okay, so we can understand this with one more example. For example, let us take four different circles. Okay, four circles are there in which the radius of each circle is r, four identical circles. And if you will add the surface area sorry, if you will add the area of all these circles, so area of one circle is pi r square. So basically, the area of one sphere is equals to 4 times the area of a circle having same radius. So if for example, if you are having one sphere and one circle, so circle is basically a 2D shape and a sphere is a 3D object, but radius is same in the both the cases, okay. So if radius is same for both sphere and circle, then the area for then 4 times into the area of one circle, that's equals to the area this, or we can say the total surface area of a sphere, right? So next we'll learn about the volume of a sphere. Okay, so what do we mean by the volume of a sphere? So it means the space occupied by the sphere. Okay, so the space occupied is basically the volume of the sphere. So in order to understand the concept of volume better, let us take an example in which we can take two different balls. Okay, so see the two balls. Can you see the volume of red ball is, for example, it is, we are considering that volume of a red ball is half of the volume of blue ball. Okay, right. So let's try an experiment to understand this. So for example, let us take two containers, okay, and filled with water up to the brim. Okay, so immerse the red ball completely into the container. What you will observe that you can see that the water overflows out of the container. Now let's collect the water and keep it aside. Okay, then what you will do, immerse the blue ball completely into the other container, and again the water will pour out from the container. It will overflow, and you have to collect both the waters that you got from after immersing blue ball and red ball respectively. Then when you will measure the quantity of water, so on comparing the quantity of water into measuring jars, what you will see, the left jar is the water that we got after immersing the blue ball. Okay, and we'll find that the quantity of water that is in the right jar exactly half of the quantity of water which is in the left jar. So what does it mean? So it's basically an interesting concept. Okay, so basically these two spheres are having just half of the volume of each other. The sphere blue sphere is double, is having the double volume as that of red sphere. So after performing this experiment, what you understood that the volume of the red ball is half of the volume of blue ball. Okay, so by this experiment, we can understand the relation between the volume of two different spheres. Okay, and further, we have one formula also to calculate this. So now this was all the experiment to understand the concept of volume. Okay, now a mathematical representation is basically is there to calculate. So the volume of a sphere is given by this formula 4 upon 3 pi r cube. So the mathematical formula is given by this one. So 4 upon 3 pi r cube, where r is the radius of that particular given sphere. Okay, then we can easily calculate the volume of any given sphere of given radius. Okay, so this was all about the surface area and volume of a sphere. Now we can proceed to the volume as well as surface area for hemispheres. So let's proceed to hemisphere. So as you can see that hemisphere is just the half. Okay, if we cut the sphere into two, okay, into two equal halves, then the one portion that we are getting is basically nothing but a hemisphere. Okay, so here we can see that take a sphere and cut it into half. Okay, so two hemispheres you will get. Okay, so a sphere gets divided into two equal parts, and these two parts are called as hemisphere. Okay, so now hemisphere, as you can see that it's having two surfaces. One surface is curved surface, as you can see, and one surface is a flat surface, which is called as the base of the hemisphere. Right. Okay. Now, what we'll see that how we can find the total surface area in case of a hemisphere. Okay. The total surface area basically of hemisphere the is given by the sum of the areas of curved surface plus area of the flat surface. So as you can observe it over here, so surface area of a curved surface is exactly for a hemisphere is exactly half of the surface area for a sphere. So it will be for sphere we are having 4 pi r square. So which means that for half of the sphere, that is a hemisphere, will having a surface area that will be equal to 2 pi r square. Okay, 2 pi r square, that is a curved surface area for a hemisphere, plus flat surface area, that is nothing but a circle. So it will be pi r square. Okay, so 2 pi r square plus pi r square. So altogether we'll get total surface area for a hemisphere, that will be nothing but 3 pi r square. Okay, that is the TSA for hemisphere. So that you have to keep in mind. Okay, 3 pi r square, that is the final formula. And lastly, we can observe that uh, it is equals to just pi r square plus pi r square plus pi r square. So three times. So for example, if you are having a circle, which is having the same radius as that of a hemisphere, then 3 times the area of that circle will be equal to the total surface area of that particular hemisphere. Okay, now let's calculate the volume of a hemisphere. So as it's very easy, as all of you know that the volume of a proper sphere is 4 by 3 pi r cube. So if you are cutting that in two equal halves, then the volume of a hemisphere, the space occupied or volume of that will be just half of the volume of sphere. Okay, so exactly half of the volume of a sphere. So directly we can write that it will be nothing but 2 by 3 pi r cube, because for a sphere we are having 4 by 3 pi r cube. So in case of hemisphere, you will get 2 by 3 pi r cube. So all these four concepts that we understood over here was all about spheres and hemispheres. So that's all from my side in this session, and we'll continue with the more conceptual questions based on these concepts in our next coming Zoom session. So that's all from my side. uh, do practice questions from your side also, and go through this video class for easy understanding about these concepts. Assalamu alaikum to all of you.